Welcome to today's class. Today we shall be looking at changing components. Changing the components in a circuit. How does it affect a circuit? Look at this circuit. Circuit was discovered by Alexander Volta. Alright? Look at this circuit. It's carrying two different loads. When I say load, I mean the device that uses the electric power. Okay? You remember that we have different forms of energy. So battery is another form of electrical energy stored in what as potential energy. When it is being used up, the lamp using this current from the battery, we can say is the load. All right. Now observe this circuit very well. You will discover that the key is open. Not only that, only one single wire is connecting all the components together. Okay, there's a single line of wire. Now the question is, what components were used to build this circuit? You already know. How are the components joined in the circuit? You already know. Okay, look at this connection. When we have a connection like this, where one wire is connecting all the devices together in such a way that if I put it off now, the bulb will be off at the same time, the motor will be off at the same time. We say it is a series connection. It is a what? Series connection. Why? Because they are all connected in one line. Okay, in one run, the same current flows through them. All right. Now, in series circuit, if you make a break anywhere along the loop, the current stops flowing. Neither the lamp nor the motor will work if there is a break in the circuit. Okay, I believe you now understand what this actually means. So this is an example of a connection in series. Okay, we can say the bulb and the motor are in series. Now look at this other one. Can you see a difference between the initial one and this one? You can see here we have two bulbs. The second bulb 2 has its own wire tied to the first bulb wire. Okay, and then connected to the first bulb as well. And then there's another wire coming from the source. Now, do you think this is a series circuit? You might be tempted to say, what? Yes. But the answer is no. This is not a series circuit. This circuit is in parallel. We call it parallel circuit. Why? Look very well at where this wire from the bulb is connected to, and then the wire from this other bulb is connected to. It's not connected to the bulb directly. It's connected there. The two wires are joined together. That is, the source of the wire coming from the battery is joined with the other wire coming from the second bulb before it is not connected to the bulb itself. So if I disconnect this first bulb and my key is on, my second bulb will still light up. That is why I would say this one is in parallel. So it's a parallel connection, not a series connection. All right. Now, here are three circuits with different components. Okay, we have circuit A, circuit B, and circuit C. They have different components. What do you think would happen if one of the lamps in circuit B was unscrewed, and why? If we remove one of the bulb or lamps in circuit B, what will happen? You already know, right? Current will still flow, 1. Then the bulb will light up more. Okay, the bulb will burn more. Okay, why? Because the energy is being, the workload is being reduced or has been reduced. Okay, the workload has been reduced, so the lamp will light up or burn more. The lamp in circuit A seems to be brighter than the other. Why? Simple. Circuit A has what? Single lamp with the same battery. All of them having the same battery. Hope you know. Yes. Less work is done. And if you look very well, even the wire for circuit A is also short. Is it not? Yes. So less work is done in circuit A, hence the bulb will light up very well. So the load, the wire, and the energy all contribute to making the bulb light more than circuit B and C. Now, how do you think adding a buzzer or motor to each circuit would affect the brightness of the lamp? If I add a buzzer, it will reduce it, right? Yes, because I'm adding a load to it. Am I right? So if I add a buzzer to it, it will reduce the load because I'm adding a buzzer to it. Alright? And finally, how do you think adding a battery every time you add a lamp would affect the brightness of the lamps? Why would this happen? So we are trying to add a lamp and a battery, a lamp and a battery, a lamp and a battery. The glow or the first one, if I add a lamp and a battery, okay, just one lamp and one battery, I will still maintain this glow. All right, and because it is series, I will still maintain the same current flowing through them. Okay, and the bulb will still be glowing. But look at B. B has two bulbs being used using one battery. Okay, and now add another one battery and then just one bulb. What will happen to the brightness of B? Will it go down or it will increase? It will increase a little. Yes, it will increase a little. And the same will go for C as well. C has three bulbs and one battery. I now add another battery and then I now have what is it called? Just a single bulb added. So it means that C will now be bright as B. Are you getting it now? Yes, C will be bright as B because currently B has just two bulbs and is bright like this. If I add another extra bulb to it and an extra battery, it will be more brighter. Then this one has just one battery. If I now add another battery and another bulb, I now have two batteries, four bulbs, so it will give me the brightness of B. I don't know if you understand what I'm saying. I believe you understand. Okay, let's say currently B has two bulbs and is bright like this. If I now add another bulb and another battery, I now have four bulbs, two battery, which if I divide by 2, it will give me two bulb, one battery. Do you get it now? And it's also the same series connection, so it will give me the brightness of B. I want you to watch this video and get a clear understanding of what we are actually saying. Okay, the effect of components or how component affects current and then performance of materials connected to current.
In this video, we're going to go over series and parallel circuits as it relates to the brightness of a light bulb. So right now we have one light bulb. I want to show you how bright it is when I apply 3 volts to this light bulb. As you can see, it's pretty bright. And if I use the entire 6 volts on it, it's going to burn out, so I don't want to do that. Now let's see what happens when we put another light bulb in series with this one. So here we have 2 light bulbs in series. Notice that the brightness decreased. The 2 light bulbs are not as bright as the individual light bulb before. The reason being is each light bulb carries resistance. Now these are identical light bulbs. When you put two resistors in series with one another, the total resistance increases. And according to Ohm's law, whenever you increase the resistance of a circuit, keeping the voltage the same, the current is going to decrease. And that's why these two light bulbs, that's why they're not as bright as the first one. Is because there's less current flowing through the 2 light bulbs due to the increase in resistance. So now we have 3 light bulbs in series with one another. As you can see, the brightness has been further reduced due to less current flowing through these 3 light bulbs. And so that's the disadvantage of series circuits. When you put multiple light bulbs in series, the brightness decreases. Each light bulb has a voltage drop across it. So the voltage across each light bulb would be approximately 1 volt because you have 3 volts connected across all 3 light bulbs. So because the voltage across each light bulb is less, there's going to be less current flowing through it. The total resistance of the circuit is 3 times as high as when we first started. And so that's the main reason why we see this decrease in brightness, is because there's less current flowing in the circuit. So here's the first light bulb again, and you can see it's much brighter than the 3 light bulbs in series. Now what we're going to do now is we're going to connect another light bulb in parallel to this one, and we're going to see if the brightness is affected at all. Now we have the 2 light bulbs in parallel with one another, and as we could see, they are equally bright. The reason for this is because both light bulbs are connected directly across the source. They both have 3 volts across each light bulb. As a result, the same amount of current is flowing through these 2 identical light bulbs. And that's why when you connect light bulbs in parallel with each other, the brightness is the same. It doesn't reduce because the voltage across each light bulb is the same, which will induce the same amount of current, assuming the 2 resistances are the same for each light bulb. Now we have 3 light bulbs in parallel with each other, and the brightness has not decreased. Each of these 3 light bulbs have 3 volts across them, and so the same amount of current is flowing through each light bulb. Now the only thing that has increased is the total current being drawn from the battery, because it's powering 3 light bulbs, so it takes more energy from the battery. So make sure you understand that whenever you have multiple light bulbs connected in series, the brightness will be reduced because the current flowing through each light bulb is reduced. But whenever you have 3 light bulbs connected in parallel with one another, the brightness remains the same because the current flowing through each resistor is the same. But the total current being drawn from the battery, that is increased. It's 3 times as what it was when you had one single light bulb.
Welcome back. I believe in this class we've learned that changing the number of type of components in a circuit affects the way the circuit works, right? And the adding lamps without adding batteries result in the lamp burning less brightly. Okay, so that brings us to the end of the lesson. Remember to build your circuit and complete your assignment. Stay safe.